Hi everyone, welcome to V Karnataka KCET and Boards. I am Diksha Kaushal, your chemistry master teacher. And today we are going to do chemical kinetics practice. So I hope so you all are ready for the practice sessions. So as I was seeing your comments and so many of you were commenting that ma'am we want more of the practice sessions, right? So that's why I am here with this practice session. But guys, you also need to be disciplined here, right? So if I am here, I want all of you to have one pen and one notebook and write down everything and try to solve yourself, because today I have picked up previous year questions of KCET so that you can get an idea what kind of questions are frequently asked in your KCET exam from chemistry section, right? And today we are going to talk about chemical kinetics. So yes everybody, Khush, Mohit, Prabhu, Abhishek. Yes, hello. So, am I visible? Am I audible? I hope so. I am audible also. Yes. So, am I visible? Am I audible? And how's your energy? How's the enthusiasm? And are you preparing for your boards and KCET? Right, boards and KCET, whether you're from state boards or any other board, right, and for also KCET, right. See, it is very important to balance these two things together along with the school, right? So that's why we are here to help you, right? Okay, so should I start the class? Everybody in the chat box, should I start the class or not? Okay, now let us start the class. I want all of you to also get motivated and try to do questions yourself, because in the exam I will not be there to hold your hand and say this is A question, this is B, this option is C is correct, D is correct. No, right? In the exam hall you will be alone, but I can be here with you, right? That's why I'm here to teach you, so that in the exam hall you can do that yourself with lot of confidence in yourself, right? Okay, so let us start this session without wasting any time, and here's the first question on your screen. Yes everybody, yes, I want the answers in the chat box. Okay, it's a very simple. See, these are the exact questions from your KCET that I have picked up. Very simple questions, right? But good questions. Why good questions? Because you know the topics that I told you when I was teaching you chemical kinetics, the same topics they are asking you, but in a very different way they are asking you. And I totally love the way they have asked the question. If you have concept clarity, the basics are clear, then definitely you will be able to answer these kind of questions, right? Okay, so now the first question is, for a reaction, the value of rate constant at 300 Kelvin, the temperature is given to be 300 Kelvin, right? This is the temperature that is given to you, that is 300 Kelvin. Then this is the value of rate constant, that means K is 6.010 raised to power 5 per second, right? The value of Arrhenius factor at infinity high temperature. Now they are saying that if the temperature will become, now at 300 Kelvin, this is the rate constant. But now they are asking you, what is the Arrhenius factor at infinite temperature? Right, the temperature is infinite. So do you know what is the relation of Arrhenius constant, rate constant and temperature, activation energy? What is that formula? Should I write the formula here for your help? Okay, I'm writing down the formula here. The formula is K is equals to A e raised to power minus EA by RT. That is your formula, right? This is your formula. Now, they are saying that this temperature is infinity. So, K is equals to A e raised to power minus EA divided by R multiplied by infinity. Right, R multiplied by infinity is nothing but anything multiplied by infinity is infinity only. That means this will be by EA by infinity. Now anything which is 1 by infinity, that is always equals to 0. That means here this will be A e raised to power 0. Right, anything raised to power 0 is always 1. Anything raised to power 0, infinity raised to power 0 will be 1. Right, anything raised to power 0 is 1. That is actually a contradictory thing. This is actually a very controversial question in math, but I have written it here, but it is actually a very controversial question. What you need to understand, anything raised to power 0 is always 1. Always 1. Right? So here we can write this is 1 and this is k. So k is equals to a. Right? And they were asking us to find out the value of a. So that means a will become equals to k. K is given to be 6.0 into 10 raised to power 5 per second, right? So that means that is the value of going to be, the same value is for A. That is Arrhenius constant. So which is the correct answer? Which is the correct answer? I have already written the correct answer here. So D will become the correct answer, that is 6 into 10 raised to power 5 will become the correct answer for your first question. That was your KCET question. That was simple, right? Now, are you getting that confidence that yes, if the basics are clear, concepts are clear, you can definitely crack. Easily, you can get into your favorite favorite engineering college, right? Okay. So, what you need to have a strong conceptual knowledge. If the knowledge is not good, then definitely you will find the question of boards also difficult, right? Okay. So, now, second question on your screen. Let us try to do that. Okay, try to do this yourself. Okay, try to do this yourself. Is my screen blurry? Is my screen blurry, or only to me it is blurry? Is my screen blurry to everyone here? Okay, I think that's to me only. Is my screen blurry, guys? No? That is fine, right? Okay, I think to me only it is like visible blurry only. Okay, no issues. No, it's clear? Okay, perfect. Then it's perfect. Then it's perfect. Okay. Now, the second question is the rate constant K1 and K2 for two different reactions is this and this respectively. The temperature at which K1 equals to K2. Right? Again, a very simple question. K1 is given to you, K2 is given to you. You just need to make them equal. Right? So, what we will write here, K1 equals to K2. What is K1? K1 is 10 raised to power 6 into e raised to power minus 2000 divided by t equals to 10 raised to power, this is 16 and this is 10 raised to power 16. And what is the value of K2? That is equals to 10 raised to power 15 multiplied by e raised to power minus 1000 divided by t. Right, that is your second thing. Now, we will just try to calculate the value of t here, right? So, it will become 10 raised to power 16 divided by 10 raised to power 15 equals to, and this will become equals to 10 raised to power minus 1000 by t divided by e raised to power minus 2000 by t, right? And this will become equals to, here it will be 10 raised to power 16, okay? When it will go in the numerator, it will become 16 minus 15, right? Okay, right? Or you can just simply write it as 10 raised to power 16 multiplied by 10 raised to power minus 15. That will become 16 minus 15. And what about this one? It will become e raised to power minus 1000 divided by t. When it will go to the numerator, the sign will change here. It will become positive. So, it will be plus 2000 divided by t. Right? Okay. So, it will be 10 raised to power 1. 10 raised to power 1 equals to e raised to power 1000 divided by t. You can take the log, take log on both sides, take log on both sides. It will become natural log 10 is equals to natural log e raised to power 1000 by t. Now see, natural log and e are opposite of each other, so they will cancel out each other, right? And it will become 1000 divided by t, and this natural log converted into log base 10. So that will be 2.303 log base 10 of 10. Now log base 10 of 10 is 1. So it will become 2.303 equals to 1000 T, and here T will become equals to 1000 divided by 2.303. That is the answer for your temperature, right? That will become the answer for your temperature, right? Okay, right? Anything divided by a 0 is okay, you just deleted the message. Okay, so this is 1000 by 2.303. This is Kelvin. Okay, this is the unit they have given us, right? Okay, so here answer will become C is the correct answer. Is that clear? Okay, guys, so C will become the correct answer. What we did here, they were giving us K1 is equals to K2. We just put the value of K1 and K2 here, and after that we applied some mathematical concepts here, and we got the temperature as 1000 by this Kelvin, right? K means Kelvin. Okay, yes. Now the next question on your screen. Try to do it yourself, everybody. Try to do it yourself, everybody in the chat box. Yes, everyone. Half-life of a reaction is found to be inversely proportional to fifth power of the initial concentration. I am taking initial concentration as A naught. They are saying that the half-life, that means T half of this is T half is directly proportional to A naught, it is inversely proportional to A naught raised to power 5. This is what they are telling in the question, right? Okay, this is what they are telling in the question, right? Now, I told you when we were doing the theory part that the direct relation is T half is directly proportional to A naught raised to power 1 minus n, right? So that will become, it is inversely proportional to A naught n minus 1. That means if I equate these two things, here T half is inversely proportional to E naught raised to power 5. Here it is inversely proportional to A naught raised to power n minus 1. That means, can I say n minus 1 equals to 5? So n will become 6 here. So that will become my correct answer. So C will be the correct answer here. So C is going to be the correct answer here. Got it? How C is the correct answer, how B is not the correct answer? They are saying that half-life of the reaction, T half is inversely proportional to A naught raised to power 5. But we know that generally, this is a general like relation that we know between half-life period and A naught, right? Okay, so half-life is directly proportional to A naught raised to power 1 minus n. If we invert this thing, it will be like this. If we invert this thing, it will be like this. A naught minus 1 minus n. That means it will be A naught n minus 1. So now it is inversely proportional to n minus 1 and 5. Right, so that is why we are going to equate these two things and we will get the answer as 6 is the correct answer. Got it, everybody? Right? Okay. Okay, guys. Everybody in the chat box, let me know in the chat box if you're able to understand these questions or not. Right? Okay, I want to see that in the chat box you're able to understand this or not. Next is a first order reaction is half completed in 45 minutes. Right? It is half completed in 45 minutes. Right? How long does it need 99.9% of the reaction to be completed? Right? We want 99.9% of the reaction to be completed. First, as I told you, usually they will ask you question based on first order reaction only. Right? Okay. Yeah, that is true. Chemical kinetics is the most scoring chapter. It is easy. The questions are predictable. It is very simple, right? And definitely you will get around maybe 3 questions from this. Easily you can get 3 to 4 questions from here. That is why this is so important. Okay, got it? Yes. Okay, yes, Rohan, I am here only. I'm not going anywhere, right? Don't worry about that. So first order reaction is half completed. That means they are saying that T half is equals to 45 minutes. T half is 45 minutes. How long does it take for 99.9% of this reaction? Now tell me, students, you need to calculate the value for how long does it take for this one. So K is equals to 2.303 by T. So you can just reciprocate this thing here. So it will be log base 10. That is your initial concentration. That will be 100. Right? I told you whenever the concentrations are given in terms of percentage, take the initial concentration as 100. Take initial concentration as 100, right? And here they are saying when 99.9 of the reaction to be completed. That means out of this 100, 99.9% is completed, right? So here that means what we need to do is 2.303, this is divided by K, this is log base 10, 100 by, this is when you subtract 100 minus 99.9, so that will be 0.01, right? That will be 0.01, okay? Yes. So now that means from here you need to calculate the value of K, right? We don't know the value of K. Rest all the things we know here, right? So how to calculate the value of K here from this one? So it will be 0.693 divided by K is equals to 45 minutes, right? So that will be equals to, K will be equals to 0.693 divided by 45, right? That is going to be the answer, right? Okay, guys. Let us calculate this, everybody in the chat box. Let us calculate this. Let me see what is the answer and calculate yourself as well, right? Calculate yourself as well. I'm going to put the same value here only, right? So you can put the same value here. That will be, just don't solve it here, right? Put the value of K as 0.693. This is multiplied by 45. You will get the time in, minutes, right? You will get the time in minutes. Okay, everyone? Okay? So it should be 0.1. Okay, so 0.1 will be, I can just, time is equals to 45 multiplied by 2.303 divided by 0.693. This is log base 10. This is 100. This is 0.1 means this is going to be 10 here. So it will be 45 multiplied by 2.303 divided by 0.693 log base 10, 10 raised to power 3. Right? Okay. So this is 10 raised to power 3. Now we know that the thing that is in the power will come in the front. So it will be 45 multiplied by 2.303 divided by 0.693. This is 3 log base 10. That will turn out to be 1 only. Right. So here answer will be this one. Right. So now you just need to calculate this thing here. It will be approximately 2. I'm just calculating the approximate answer here. Right. Approximately 2 here. And something around, wait a minute, something around, how much time? Wait a minute, minutes we need to calculate firstly, right? Okay, wait a minute. So this should not be exactly cancelled with each other. So this will be, this is 3, this is 0.693. Right? So talk about these two things. This is approximately 3 times. Right? Just give me a second. In hours they're asking us na, how to make this calculation easy. 2.3, this is 6.969. This will be approximately 3 times. It will be cancelled, right? So it will approximately 3 times. This is 2.3. This is 2 and this is 0.6. If I take 110 here, right, just making approximate value, I'm just calculating the approximate value here. If I make 110 there, so it will be 6.93. 2.3 and 6.9 are approximately 3 times. So can I say that this is approximately 3? Because in the exam you will not have calculator, no? So how can you solve this? So it will be approximately 3, right? And this will be approximately cancel out. It will be approximately 450 minutes, right? So now we need to find out which is very near to 450 minutes, right? If you talk about in 10 hours, you will have 60, we will have 600 minutes. This will be multiplied by 60, multiplied by 60, multiplied by 60, multiplied by 60, right? So it will be, this will have multiplied by 60, so it will have 600. This will be 1200, right? Definitely not, it will be 6, 5, 30. It will be 300, right? What about this one? Till here, we can't find anything which is near to 450. This can be a little near. This also can be a little near. Now, 750. 75 into 60. Here, 10 will cancel out each other. 75 into 6, 6, 5, 30. 7, 6, 42. 40, 45. Exactly, we are getting 45. Right, so that means 7.5 is the correct answer, right? Okay, so do the approximations and then solve it, right? So approximately it is coming out to be 450, which is approximately equals to 7.5 hour, right? So answer is going to be A is the correct answer. Okay, so answer is going to be A is the correct answer, 149.54. See, it's easy to calculate that on the calculator and say it is 149.54. I know that. But you know, in the exam, it will be very difficult for you to calculate. Like that will be the big problem, right? Okay. So to make it easy for you, just do approximations, and in KCET, they will not give you very near options. You can see that options are very like far away. It is 450, it is 600, it is 1200, it is 300. Right? In NEET or in JEE, they give options that are very near to each other. One is 450, other is 460, 480. Then you have to do the direct calculations, right? But here you don't need to do that, right? Okay. Now, next question on your screen is the rate of the reaction of this reaction is given by the equation. This is the equation that they are giving you. If concentration is expressed in mole per liter, the unit of K they are asking you, right? Okay, the rate of the reaction they are saying, right? The rate of the reaction, very simple thing. The rate of the reaction is given to be this one. So can I say it is a second order reaction? It is a second order reaction. Simple, guys, second order reaction, right? Now, we know that the units of K, the general units of K, anybody in the chat box? Units of K are mole per liter 1 minus n per second. N is the order, so n is going to be 2 here, so it will be mole per liter 1 minus 2 per second. So it will be mole per liter, and that is minus 1 per second. So minus 1 is multiplied to this mole, it will be per mole liter per second. So it will be per mole liter per second. So B will become the correct answer. Okay, so B will become the correct answer. The generalizations you have to understand, right? The general ways, right? It's a very simple chapter, right? The general things, the general formulas that you need to understand. After that, the thing is very easy, right? Now the same kind of question. See, if these are the previous year question, you will get an idea what exactly they are asking. For a reaction A plus 2B products, when concentration of B alone is increased by, now very important question, right? Now they are saying that for a reaction this, when the concentration of B alone, for this I will give you a trick. For every, see, in competitive exam, you need to have tricks, right? In board exams, it is not necessary. Right? In competitive exam, you need to have tricks because you have some time there, right? You have time limitation. So that's why you need to be very fast for that. So the trick is that the new rate equals to x raised to power n times the old rate, right? Here what is x? X is the concentration, whether it is doubled, tripled, right? What you have done with the concentration. And n will become the order of the reaction. N will become the order of the reaction. Now this is the trick that you need to remember. Now I'll tell you how to apply this trick, right? So when the concentration of B alone is increased, half-life remains the same. They are saying that when B alone is increased, half-life is same. Half-life is same. Half-life is same. Here, if they are saying that when you increase the concentration, but there is no effect on the half-life. See, I told you one thing, so there are two concepts involved here, right? For half-life, we know that T half is directly proportional to A naught 1 minus N. If we say that if N is equals to 1, then T half is independent of concentration, right? This we know because when n is equals to 1, that this will become equals to A naught raised to power 0, that will equals to 1. So that means then T half is independent of the concentration. Here they are telling you one hint about the T half, that the concentration, A, not with this one, I am talking about this line, A, B alone is increased, T half remains the same. That means it is independent. So according to question, T half is independent of B. Independent of B. That means with the respect to, B, it is first order reaction. It is first order reaction. First you tell me, are you able to understand this thing or not? That with respect to B, it is a first order reaction. Are you able to understand this or not? Can I write here that the rate of reaction is, this is rate of the reaction, the final will be B raised to power 1. A we still have to find out. A we are still finding it out, right? Next they are saying if the concentration A alone is doubled. Now they are saying that A concentration is doubled, okay? The next hint that they are giving us is for the concentration of A, right? Now they are saying that A concentration is doubled, then the rate remains same. Now you have to apply this concept here. Then rate is same. Then rate is not T half. Rate is same. Now for this, remember one thing. That means rate nu is equals to x raised to power n rate of volt. How much concentration is doubled? 2 times it is doubled. So instead of x, just apply 2 raised to power n rate of volt. Just apply 2 raised to power n rate of volt because concentration is doubled. Right? So that means x is equals to 2. Right? So here it will be 2 raised to power n R of volt. Right? Now we know that from question we know that there is no change in the rate. That means if we equate these two things, 2 raised to power n is equals to 1. When it should be equals to 1? When n is equals to 0, only then it will be equals to 1. Right? That means order of the reaction should be 1 with respect to A. Now students, tell me, that was a good question. Now tell me, are you able to understand these two concepts? This is also a very important concept. This is also a very important concept. right? Both of these concepts are very important. Trust me on that. They have asked you this question in KCET, right? It is a question of, I think, 2023 only, right? And the same kind of question they ask in NEET as well, right? So these kind of question they will not ask in board exams, but yes, they will ask these kind of question in competitive exams. So I will consider it as a good question of KCET, right? Okay, and you should know these kind of questions, right? Only few students will be able to answer, and only those students will be the ones who will get the seat in a good college, right? So these kind of question which will determine your rank, right? And it's not a tough question, it's a very easy question, right? So we can say that this is a raised to power 0, right? A raised to power 0. So overall overall order is 1. If overall order is 1, in that case rate units is equals to see, there are so many steps involved here. Units is equals to mole per liter 1 minus n per second. Because here n is equals to 1, so it will be mole per liter 0 per second. So answer will be per second. Answer is going to be A is the correct answer, right? Okay, A is the correct answer, right? Okay, understood. Simple, everyone. Simple, easy, right? Okay, will you be able to do these kind of questions in the exam? Can I expect that from you guys? Can I expect or not? Everybody in the chat box, can I expect these from my students or not? Right? You will not disappoint me in the exam, right? Everybody, let me know in the chat box. Let me know in the chat box. Yes, come on, everybody. Yes. Khush Mohit, Rohan, Prabhu. Yes, Abhishek. Yes. Now, you guys don't like talking to me. Am I that bad? Huh? Am I that strict teacher? Do you find me as a strict teacher or a very sweet teacher? What do you feel? What kind of teacher? What kind of title you will give me? A strict teacher or a very sweet teacher? I think I'm a mixture of both. Sometimes I get angry on students, but sometimes I'm very sweet. Right? Then I don't understand why you guys don't like to talk to me. Right? Am I that strict that you were like, okay, we don't want to talk to you, ma'am. Just like a robot, you come and just, ma'am, teach and ma'am, go, ma'am. We don't want to talk to you, ma'am. Is it? So what kind of teacher am I? I want to know that in the chat box. Sweet dosa, ma'am. Sweet dosa, ma'am. Yeah. Like in the streets, they are making that chocolate dosas, no? So in that way, I'm a sweet dosa, है ना? With lot of sugar, and sometimes the dosa is also very angry, right? So yes. Now next is if the rate constant for the first order reaction is K1, they are saying the rate constant for the first order reaction is K, sorry, it is K. The time required for completion of 99% of the reaction is given by 99% of this you have to complete, right? So rate constant is time required 99%. So T is equals to 2.01303 K, right? Log base 10. Now 99% means 100 is the initial. 100 minus 99 you will do. It will become 2.303 divided by K. Log base 10. 100 by 1, right? 100 means this will be 10 raised to power 2. It will become equals to 2 into log base 10. Now we know that the value of log base 10 is, log base 10 of 10 is 1. So it is 2.303 multiplied by 2 divided by K, that is 4.606 divided by K. So answer is A is the correct answer, right? A will become the correct answer, right? Okay, A will become the correct answer, right? Okay, guys, very good, very good. Now, next question is, the rate of the gaseous reaction is given by expression this. And that is the rate is given to you. If the volume of the vessel is reduced to 1/2 of the initial volume, the reaction rate as compared to the original rate will become equals to. Okay, so firstly they are giving us this is the rate of the reaction, right? This is the rate of the reaction. So you can just write it down here. R is equals to K, A raised to power 1, B raised to power 2. Right? Now students, important thing I am going to write here, right? That they are telling us that, what they are telling us that the volume of the vessel, that is V2. I am saying that the final volume is V2. V2 is half of V1, right? So if I say that the V2 is volume of the vessel is reduced to 1 by half of the initial volume. If volume is increasing, concentration is decreasing. Do you agree or that? Volume and concentration are inversely proportional to each other. The more volume you add, the concentration of that thing will decrease, right? For example, you have a glass of water, you are thinking that it's, ma'am, too sugary for me, it's too sweet, right? Ma'am, what I need to do, I'll say add water into it. What else you can do, right? So you will add water into it, right? So that means you are diluting, you are decreasing the concentration of sugar, right? So the same thing we are doing here. That means if volume is increased, volume is decreased, concentration will be increased, right? So concentration of 2, you can say that concentration of 2 will be 2 times of C1, right? Okay, can I say that? So here can I say it means A concentration will be 2 times A, B final concentration will be 2 times B. Now this was the important thing, right? This was the important thing. Volume and concentration are inversely proportional to each other, right? So if volume V2 is equals to half V1, then C2 is equals to 2 into C1. That means final concentration is double of initial concentration. Final concentration I am taking as A dash, that is double of initial. Final concentration I am taking as B dash, that is initial concentration, that is double of initial concentration. So new rate will become R dash is equals to K is equals to 2A, this is 2B square, and this is K, this is equals to 2 okay, that was right only, right? It will be A, and here it will be 4 into this is B square, so it will be 8KA B square, right? So that will become equals to nothing. This is nothing but this is R only, so it will become R dash is equals to 8 into R, right? So now they are saying the reaction rate as compared to original rate is 8 times, no? Yes. So C will become the correct answer, okay? As compared to the original rate, it is getting 8 times, right? It is getting 8 times. Okay, guys? Okay, everybody in the chat box, are you able to understand this or not? Right? B nahi, C. C is the correct answer. This is the original rate. This is the original rate. This is the final rate, right? So final rate is 8 times the original rate, right? Okay, final rate is 8 times the original rate, right? Okay, okay everyone. Next question on your screen, you have higher order, that is greater than 3 reactions are rare due to. Why we always say that more than 3 molecules, it is very difficult for them to react in the slowest step, right? Molecularity more than 3 is very rare, right? Very like impossible it is. Why? Shifting of equilibrium towards reactant due to elastic collision? No, nothing like that we have studied. Loss of active species on collision? That active species on collision? No, right? It can be the answer, but not exactly the right answer. Low probability of simultaneous collision of all reacting species. So for example, there are so many species that are colliding with each other. So 4 species, it will be very difficult for them to collide because the probability factor will decrease here, right? So that is your correct answer. Increase in entropy, no relation with that, right? So answer is increase in the probability. The probability will decrease here. That is why decrease in the probability factor, and hence the more than 3 molecules, it is very difficult for them to collide, give effective collision, right? Okay. Ma'am, if it is 1 by 8, how was that? No, it is not 1 by 8. 1 by 8 means you have done mistake over here. We are saying the rate, the concentration are increasing. That means definitely the rate is going to increase. That means you are taking A dash is equals to 1 by 2A. You are taking B dash is equals to 1 by 2B. And this is regarding the volume. They are telling that volume is half, concentration is doubled, right? So rate will also increase. It will be doubled. Sorry, concentration will increase and hence rate will increase here, right? Okay, Prabhu. Okay, Prabhu. Then you have, for an elementary reaction, this is the elementary reaction. That means this is just occurring in one step. The rate of appearance or at time t is given by this rate of disappearance of B you have to find out. So rate of appearance are always in positive. So dc by dt, this also beta I have covered it in so much detail. dc by dt is equals to dc by dt, rate of appearance or rate of disappearance that will never be divided by the moles, right? So that is equals to, that is given by 2.8 into 10 raised power minus 3. Now let us see the rate of reaction here. Rate of reaction will be equals to, they are talking about B and C here. So in terms of B and C, let us see. In terms of B, it will be, because it is disappearing, so it will be minus dB by dt. Now here the number of moles is 3, so it will be 1 by 3. C is appearing, sorry, B is disappearing, C is appearing, so it will be plus 1 by 4 dC by dt. Now why I have divided it by number of moles? Because in rate of reaction we divide it by number of moles, right? So from here I can say that dB by dt equals to, dB by dt they are asking, they are asking you the rate of disappearance. Rate of disappearance is minus dB by dt. So they are asking you the value of minus dB by dt. So minus dB by dt is equals to 3 by 4 of dC by dt. dC by dt is given to be 2.8. So it will be 2.8 multiplied by 10 raised power minus 3. And this is going to be the correct answer. 3 by 4 into 2 into 10 raised power minus 3. Right, that B will become the correct answer, right? B will become the correct answer here, right? B will be the correct answer. Is that clear, guys? Is that clear? Is that clear? These all are the question of your previous years only, right? I am not making it like myself, right? So these are your previous year questions because I wanted, so students what they feel, either they feel it is very difficult or they feel it is very easy. It's not that easy to crack KCET. You need to be well prepared for KCET. Yes, if you are well prepared for KCET, then definitely you can crack it. This is the proof, right? Okay. Now, next question is, the rate constant of a reaction is given by this. This is the rate constant of the reaction, right? It is given by K is equals to PZ e raised power minus EA by RT. Under standard notation, in order to speed up the reaction, which of the following factors has to be decreased? Now, probability of more collision should increase. This should to be increased. This Z is your, again, frequency. How many molecules are colliding? This is the collision frequency. This is the orientation of the molecule. That should also be right. This is the collision frequency. That should also increase. More collisions, more reactants will be formed. And this is your activation energy. Now tell me one thing, activation energy, should you decrease it or should you increase it? Activation energy, right? This is the graph of activation energy, right? This is the graph of activation energy. This is without any catalyst and this is with the catalyst, with a positive catalyst. So this is your activation energy, and when you have a positive catalyst, the activation energy will decrease so that less energy is required for the reactant to jump up to the activation energy, to cross that barrier. That is why we need to decrease the activation energy if we want to have more, like we want to increase the rate of reaction. So EA should be increased, that is activation energy should be increased, right? Okay, Yes, everybody. Which question you want me to repeat, Prabhu? Which question is this? This one or the previous one? Which question? I think we are just left with one more question. Yes. Which question you want me to repeat, Prabhu? Hanji. Which question? This one or the last one? This one or the last one? Okay, by the time he is like thinking, I'll just explain you the next question here. The plot of T half, previous one, that means this one. See, very simple. As I told you, have you seen my that one shot video, not one shot video, the theory videos of chemical kinetics? First thing is rate of appearance and disappearance, right? All the things that I have mentioned in rate, like in the first lecture of chemical kinetics. The whenever you are calculating the rate of appearance and disappearance, appearance will be positive and disappearance will be negative. Firstly, rate of appearance and disappearance, there will be no division with the number of moles. It will be simple dC by dt, dB minus dB by dt. In rate of disappearance, you have minus because reactant is decreasing. In appearance, you have positive. Rate of appearance, they are given to be this much, and disappearance, they are asking us. Now, how to have that connection? The connection is rate of reaction. But in rate of reaction, I want to see for B and C only. But in rate of reaction, the thing will be divided by number of moles. So here number of moles of this are 3, number of moles of this are 4. So it is divided by the number of moles. I want to see the value of, I want to see the answer for minus dB by dt, that is equals to 3 by 4 dC by dt. dC by dt is given to be this. So answer will become B is the correct answer. Okay, understood? Yes, 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 yes. Now, last question of today's class, and that is the plot T half versus R naught. What is R naught? Sometimes it is written as A naught, sometimes R naught. That is the initial concentration. They are saying that is a straight line parallel to x-axis. This is your T half, this is R naught, and they are saying it is parallel to x-axis. That means it will be like this. That means whenever you are wait a minute, T half versus A naught, right? Okay, T half versus x, y versus x, right? Yes. So whenever you are increasing the concentration, the T half is remaining same. That means, can I say that T half is independent of concentration? T half is independent of concentration. It is independent of the concentration. From here, can I say one more thing, that if it is independent of the concentration, we know that T half is directly proportional to A naught raised to power 1 minus N. That means this N should be equals to 1. For first order reaction only, it is independent of the concentration, right? So here can we say that for first order reaction, we know that the units are the units of Kr, generally I am writing mole per liter 1 minus N per second. So it will become per second. So answer is D will become the correct answer. Right? D will become the correct answer. Right? Okay, D will become the correct answer. Now everybody in the chat box, let me know if everything is clear to you or not. And these are the kind of questions that they will ask you in your KCET exam, right? It is a very competitive exam. That means you need to be well prepared for that. You just can't think that I'll just do. Say, tell me one thing. Will you be able to do these questions without practicing? No, it's not possible, right? And will you be able to do these questions without the theory part? If you don't have basic knowledge, you will not be able to understand these things. That is why I taught you the basics first. Then I am doing the questions here. Right, so this is the thing that we are going to do, and yes, I am waiting for your comments in the comment section. What else you want from me? What are the other topics that you want me to discuss? And something really amazing is coming for your KCET and boards preparation, right? Because so many of you were asking that, ma'am, we are unable to balance between KCT and boards, right? So how to balance, how to make a timetable, everything we are coming up with, a very interesting thing. But what we need is your support. So I want all of you to share this channel among your friends, right? Share this on your WhatsApp, share this on your Instagram. You can tag me on Diksha __ Kaushal. That is my Instagram handle. And you can also connect to me on this Telegram channel. The link I have mentioned here, t.me / Diksha Kaushal Chemistry. That is my Telegram channel handle, and here you can also ask your queries, and I always see your comments also, and all the updates regarding my lectures are there on this Telegram channel. Okay, yes. Vedantu, NEET English for KCT preparation? No, 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 Rohan, right? NEET has another level, right? If you are targeting NEET also, then you can watch it. But if you're targeting just KCT, the KCT questions are easy, right? So that will be a waste of time for you. So I would not advise that. I would advise the students who want boards, they should focus on only the boards. That is why we are coming up something for boards only students. And the thing that is, see, these kind of question, they will not ask you these kind of question in boards, right? They will ask you these kind of question in KCET, right? And NEET level, like they will ask you more complex question. In JEE, they ask even more complex questions. So, right, that would not be advised, right? Okay, yes. Okay then, bye bye, take care, see you all in the next lecture, where we are going to do something really, really interesting. Okay then guys, bye bye, take care, see you.